on this computer. All right, so I want to go through just two examples real quick. So say, for instance, I have 3x squared minus 2 plus 4x plus 8. So I have these in parentheses, and they're there to confuse you. So for example, we know that there's an imaginary 1 right here. I just don't need to put it. So just like how I would regularly with distributive property, I would do the distributive property for these, just so I could get rid of the parentheses. All right, so in reality, this is saying it's 3x squared minus 2 plus 1 times 4x is 4x plus 8. And then I would go through and I would combine like terms. Okay. And then whatever sign is in front of the number, that's the sign that goes with it. So this is really 3x squared plus 4x. And then it was minus 2 plus 8. All I'm doing, I'm combining like terms. So my answer would come out to be 3x squared plus 4x plus 6. And do you realize that I wrote it in descending order? So whenever I'm presenting my polynomial, I want to write it in descending order. So I start with the 2, then the 1, and then 0. All right? That's one example. Okay. So with these two, they're two different terms. X is different from x squared. So I can't group those terms together. All right? That's a really good question. They have to be the same term within the same variable. So yes, it's x, but one of them is a different exponent. Okay? Let's look at another question. Let's make this one a little bit more something. Okay, let's put a x, let's put a 3x squared minus 7x plus 2. Let's put a minus sign out here. And let's put another minus sign right there. Minus 3, I like 3 for some reason. Why? 4x squared plus 8. First of all, I got to get rid of these parentheses. They are in the way. And again, I don't have to write the 1, but I'm going to put it in there just for the example that we're doing. All right, but I don't have to write the 1. However, I still have to go in and do the distributive property. Bam, bam, bam. And realizing that I'm doing the -1 to all the terms because it's in the parentheses. So you always want to do it with all the terms, right? Someone said it seems easy for now. This is it, I promise. So here, -1 times 3x squared is -3x squared. -1 times the -7x is positive 7x. Keep in mind, I wrote the 1 there. The questions you're going to do won't have the 1. Please remember it. So -1 times +2 is -2. Same thing here. -1 times 4x is -4x squared. And then -1 times 8 is -8. Now the next thing I have to do is I have to group my like terms. So I have a -4x squared here and I have a -3x squared there. What else could be grouped? My -2 and my -8. So I'm going to go ahead and rewrite this so that it's all grouped. -3x squared minus 4x squared. And I'm already putting it in descending order because I know that I have to do that. That's why I'm just going to do it from the get-go. All right. And then I have a positive 7x. And then I have a -2 minus 8. Now I simplify. Negative 3x squared minus 4x squared is negative 7x squared. If you realize all I'm doing is doing negative 3 minus 4, which is negative 7, and then I'm putting back the x squared. All right, then plus 7x, and this is minus 10. So that would be my answer right there. This is when we are adding or subtracting polynomials. That's basically it. Sometimes you'll have 6 numbers in here. Sometimes you'll have 10. Sometimes you'll have x to the 20th power, whatever it is. I want to do one more example. Let's make this a little bit tricky. Right here. So let's do y squared. No, let's stick back to what we're doing. Calm down, Misha. Calm down, Mr. Midnight. 3x squared y cubed plus 3xy minus 4. Let's do minus 4x plus 2 times 3. I was right, 3. 2 times xy minus x squared y cubed. So again, when I'm starting this out, I got to do the distributive property. All right. Get these parentheses out of here. They don't need to be here. Okay. So that negative times the 3x squared y cubed is negative 3x squared y cubed. Negative times the positive 3xy is negative 3xy. And then negative times a negative 4x is positive 4x, right? And then 2 times xy is a positive 2xy. And then 2 times a negative x squared y cubed is negative 2x squared y cubed. Now I have to go in and I have to group my like terms. This one has x squared y cubed, and this one has x squared y cubed. So them two go together. This one has xy, this one has xy. Them two go together. This one is the only one that's going to stand alone because I have nothing else to group it with. So if I'm going to rewrite, it's going to be minus 3x squared y cubed minus 2x squared y cubed. If you realize I'm already putting it in descending order because I know that this degree is 5. All right, this degree is 2, so that degree goes next. So minus 3xy plus 2xy. And I got my standalone person over here, 4x. All right, so now I have to simplify. So these two go together. We already know that. These two go together, and that's the standalone. So negative 3x squared y cubed minus 2x squared y cubed is none other than negative 5x squared y cubed. Negative 3xy plus 2xy is negative negative xy. I apologize. Don't let the variables fool you. It's still done the same way. If I said to you negative 3 plus 2, you would tell me it's negative 1. You're on the number line at negative 3 and you go over 2. It's still negative 1. It's just that the xy is there. It's my term. And then that's plus 4x. So then that right there would be my answer for that question. This right here. These could get long. Just so you know, It could be so many different degrees going down. You'll realize you have a degree of 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, all the way down. But then again, it's just taking your time, going through so that you're doing the distributive property properly. Then also you're combining the right like terms, and then you're simplifying the right like terms.